This is questions 1, 3 and 5 in exercise 8.5 in New Concise Project Maths 3a. We've defined the coordinates of the point on the curve y is equal to 2x squared minus 3x plus 2 at which the tangent to the curve has a slope of 1. Now in previous sections and previous videos we would have looked at how to get the slope of a line at a given point on a curve by using differentiation to get there. But this time around we're being given the slope and we've got to figure out the point on the curve where that slope will occur. So the first thing we're going to do is we're going to differentiate. So we're going to find our dy dx. So our differentiation of our y here is going to be 4x minus 3. And what this is this 4x minus 3 is a formula to figure out the slope of a tangent to our curve y at any given point x. But we've been told what the slope is this time, so we don't know the value x, but we know the slope. So what we can say is if m is equal to 1, then we can just say that our differentiation, our dy dx, 4x minus 3 is equal to 1, and we can solve this out for x. So we're going to get 4x equals 1 plus 3. So 4x equals 4, which means that x is equal to 1. So now we know that at x equal to 1, on this curve here, this y curve that we started with, we will get a slope of 1. But we are asked specifically to find the coordinates of the point, not just the value of x. So what we now need to do is take our x equal to 1, and we've got to sub it back into our original function. So it's going to be y is equal to 2 times 1 squared minus 3 times 1 plus 2, which is going to be 2 minus 3 plus 2, which is equal to 1. So from the point that we're looking for, x is 1 and y is 1, which means the coordinates of that point are going to be 1, 1, like that. Now the fact that the points ended up as 1, 1 and the slope is 1 in this question is purely coincidental. We'll take a look at question 3 and we won't get as convenient numbers this time around. So in question 3, we've defined the coordinates of the points on the curve y equals x cubed minus 3x squared at which the tangents to the curve have a slope of 9. You notice this time they used plurals both times, points and tangents. So we're expecting to get two different values out for this. So first things first, we're going to differentiate. We're going to get our dy dx, which is going to be equal to 3x squared minus 6x. And we have a slope of 9, our m is equal to 9. So we're going to say that 3x squared minus 6x is equal to 9. And now we have to solve that out for x. Well, this is a quadratic trinomial, so we're going to bring our 9 over, and we get 3x squared minus 6x minus 9 is equal to 0. Now we can factorize this out, but since the coefficients and the constant at the end are all divisible by 3, we can divide by 3 to make this a little bit easier on ourselves. So we get x squared minus 2x minus 3 is equal to 0. And this is way easier to factorize. So we're going to get x minus 3 times x plus 1, like that. And then if we solve that out further, we're going to get x minus 3 is equal to 0, and x plus 1 is equal to 0. So x equals 3, x equals minus 1. So we have our two values for x. But as with the previous question, we need to sub them back in because we aren't just looking for our x values. We need to know the corresponding y values. So when x equals 3, y is going to be equal to 3 cubed minus 3 times 3 squared, which is going to be 27 minus 27, and that's equal to 0. So we get the point 3, 0, like that. And then when x is equal to minus 1, y is going to be equal to minus 1 cubed minus 3 times minus 1 squared. Minus 1 cubed is minus 1, And minus 1 squared is 1, so we get minus 3 times 1. So it's going to be minus 1 minus 3, which is equal to minus 4. So we get the points minus 1, minus 4, like that. So our 2 points where the tangent to the curve have a slope of 9 are 3, 0, and minus 1, minus 4. Now let's have a look at a slightly different way of phrasing this question in question 5. Question 5, we've got to find the coordinates of the point on the curve y is equal to 2x squared minus 2x plus 5, at which the tangents to the curve are parallel to the line y equals 2x minus 3. So they're not giving us the slope, but they're giving us a line that is parallel to our tangent. So we've got to figure out our slope to start with. What we have here is we've got a line written in the form y equals mx plus c. So that's the way that this line has been written out. M represents our slope, so this 2 is our slope, and minus 3 is our y-intercept. But we don't need that right now, we're only looking for slope. So from our line here, we can say that m is equal to 2. And now we can go about the way we have done with the previous questions. We're going to find dy dx from our function y up here, which is going to be equal to 4x minus 2. And we know that the slope is equal to 2, so we're going to have 4x minus 2 equals 2. So 4x equals 2 plus 2, which means 4x is equal to 4, so x equals 1. And if x equals 1, then y is what we get. We put 1 back into our original function. So we're going to get 2 times 1 squared minus 2 times 1 plus 5, which is equal to 2 minus 2 plus 5, which is just equal to 5. So we get the point 1, 5, like that. And that is that.